Hi, my name is Robert. I'm a postdoc at Princeton, and today we'll be learning about unsupervised learning and specifically clustering methods. So first, just to recap, over the last several lessons, you've been focusing on a variety of extremely popular methods in machine learning and AI that all fall under the category of supervised learning, learning from labeled examples. Um, there are different kinds of supervised learning. So you learned about classification and regression, where the main difference between these is the data type of the thing that you're trying to predict. So in a classification problem, you have some discrete finite number of labels, for example, spam, not spam, and you're trying to figure out which one of these labels you should assign to a given example. So you have the text of an email, and you're trying to assign it spam or not spam. In a regression problem, you have continuous or real valued output. So these are numbers, like the number of likes you expect the post to get, the number of shares you might expect a article to get, or things like temperature, age, anything that can be put on a number scale. So the thing that all of these have in common is that we have a sense of the ground truth for each example. So we have a data set of what the correct label for each example is. Now, unfortunately, these labels are often extremely costly or challenging to collect. Or it's not clear exactly what ought to be the ground truth that we should predict. So for these kinds of situations, there is another class of problems known as unsupervised learning. So in the exercises at the beginning of this lesson, I asked you to group these numbers into 3 categories, no more, no less. So I would love to be able to sit down individually with each of you and understand how you approach this problem and the kinds of interesting solutions you came up with. But for now, I think it's worth just reflecting a little bit on what some challenges of this task were. What made this tricky for you? And if it's tricky for us as humans, how this might be tricky for machines as well, and how we could try to formalize what we were trying to do. So the first thing that you may have run into when you were trying to assign these into categories is like, what features are relevant here? What definition of similarity between these numbers should I use? You know, there's a lot of different properties of numbers that you might care about. Second, maybe you came up with some nice set of properties, but there was one or two numbers that didn't totally fit in. So 9,999 was a bit of an outlier, and you couldn't totally figure out which of your categories you should put it in. What happens in that case? And finally, how can we tell if some ways of categorizing are better than others? We have an intuition that some ways of grouping these are really bad. Like if we just randomly picked the first 4 numbers into one group, the second 4 numbers into another group, and the third 4 numbers into a third group, you get a sense that the similarity within groups is maybe not necessarily different from the similarity across groups, no matter what features you use. So how can we kind of compare different categorizations to one another, or tell a machine what kinds of categories to be looking for? Well, it may be useful to walk through some possible solutions to kind of illustrate how we might approach these different challenges. So you may have started by thinking, hey, if I were supposed to group these into 2 categories, there's a pretty obvious one, which is odd numbers and even numbers. These are pretty common ways that we split numbers into two categories. So you may have then proceeded from that to be like, well, what makes something odd or even is whether it's divisible by 2 or not. So even numbers, when I divide 2, it's clean. 4 divided by 2 is a whole integer. Whereas odd numbers, when I divide by 2, there's 1 left over. There's a remainder. So you may have thought, well, maybe there's something I could do by dividing by 3. Maybe there's one class, like these numbers in black, that divide cleanly by 3 with no remainder. So 12 divided by 3 is just 4. Then there are other numbers, like these blue numbers. When I divide them by 3, there's 1 left over, and then there's a third group of numbers, these red numbers, where there are 2 left over. So that gives you 3 categories, and you can justify it. But you may have also looked at these and said, well, that's not actually supernatural. That's not really what pops out to me when I look at these numbers. I noticed that some of these numbers have 2 digits, the ones in black. Other numbers have 3 digits, these numbers in red, and others have 4 digits, the numbers in blue. And of course, there are countless other ways to group these numbers into 3 categories. So this is the heart of the clustering problem. How do you decide which kind of assignment to make? So in this case, the relevant feature where you define similarity was the number of digits. And in the previous case, it was the remainder when you divide by 3. So those are just 2 possible features, but there are other features that you might care about as well. Okay, so when you solved this problem, you were doing unsupervised learning. I didn't tell you, here are some examples of numbers and category A, category B, category C, and then gave you some new numbers and said, is this A, B, or C? I just gave you a bunch of numbers, and you had to come up with what A, B, and C were yourself. So this is the kind of machine learning that works on raw, unlabeled examples. And the goal of unsupervised learning is typically to discover from the bottom up some structure to the data that was input. So often we don't know going into the problem exactly what we want. We're just interested to figure out what kind of structure the data has. So one consequence of this is that because we don't have labeled examples that tell our model what the right answer is, we often need ways to evaluate the results of clustering and try to get intuition about exactly what has been found. And another consequence is that typically the workflow when you're doing unsupervised regression isn't this train test split where you give a bunch of examples and then take away the labels and ask the model to predict them. You just have a bunch of data. So it's a little bit of a different way to think about a machine learning problem. Now, clustering, which is the main focus of this lesson, is a specific type of supervised learning, which is particularly popular. And it's a kind of unsupervised learning in the same way that classification and regression are types of supervised learning. So we often think of clustering as kind of an unsupervised analog to a classification problem, because the output of the clustering process is a set of groups for each data point. So you can present it with a new data point and it'll tell you what group that belongs to. So the goal of this clustering is to group our data into different sets where elements are more similar within a set than across sets. So we're trying to find a way of drawing boundaries, essentially, in our feature space that carve it up in a way that maximally preserves similarity within those boundaries, as you can see in this diagram on the right-hand side. And it's important to think of clustering as not a specific algorithm, but rather a task that we might specify lots of different algorithms to perform. So the task of clustering is just to recover clusters from data. And in this lesson, we'll be talking about a few different algorithms that have been proposed to do this in different ways. So before going on to describe what those algorithms are, I think it's helpful to think about some applications of clustering in the real world. When do you want to use clustering? And the underlying idea here is it's basically any situation where you want to discover structure, but labels are too costly or confusing. So say you work at Spotify and you just have a bunch of audio files with some metadata about the artist and whatnot, and you want to group this music into something like genres so that you can make cool playlists. How do you identify clusters of songs? Say you work at Twitter and you just have a big social network. You just have who is following who, but you want to identify communities. You want to say these people seem to be similar to each other. Maybe they have similar interests. Maybe have similar demographics. How do you discover what those communities should be? Because no one is labeling themselves in a community. And finally, say you work at a hospital and you have a big data set of medical scans, and you're trying to identify different types of tissues or different types of diseases in a way that isn't entirely annotated. So you don't have a doctor looking at every single scan in your data set and telling you what kind of tissue it is. So you want to discover this from properties of the images themselves. So those are a few applications, but I'd like you to get a drink of water, take a bit of a break, and think of some other ways you could use clustering to discover ways of grouping data, objects, items, examples together. I'll see you back in a few minutes.